All right, gentlemen, in this video, we're going to talk about introducing Chapter 4, which is quadratic functions and equations, specifically 4.1, which is quadratic functions and transformations. So quadratic functions have a really high application in our everyday life. Anything you're talking about with that you're throwing or kicking in the air, any projectile that eventually is going to come back down to the ground because of gravity, is going to most of the time take the form of a parabolic path. You can see a couple examples here with the home run derby tracker. You can see a lot of times in shapes of buildings, even this Super Mario character takes the path of a parabola when he jumps. Here are just a few more examples. You have the St. Louis Arch, you have the Golden Gate Bridge, you even have your McDonald's sign. You could actually write the equation for the quadratic function that models each one of those. I've mentioned the word parabola a couple times already, and a parabola is just basically talking about the graph of a quadratic function. So anytime I say parabola, you should be thinking a U shape. That can either open up or can open down. It cannot open sideways. Okay, what I just drew here, this is not a quadratic. Okay, that would not pass the vertical line test, so it's not even a function. So quadratics are U-shaped graphs that open up or down. Most of the time, they're going to be written in one of two forms. You have your standard form, which I just put a box around. And in this video, we're going to talk specifically about vertex form. So that's something you definitely want to write down, where it's f of x equals a times the quantity of x minus h squared plus k. That should look familiar. When we did absolute value functions in section 1.6, that was some, or I'm sorry, not 1.6, in section 2.7, that's something that we talked about, where we had those same variables a, h, and k. We are going to have another axis of symmetry, again, something similar. That's going to divide the graph into two equal mirroring images. The equation for that is always x equals a number to give us a vertical line, and it's always the h value, so it's always going to be the x value of the vertex. The vertex is hk, so remember, we're always going to take the opposite of this h value and the same as this k value to get the vertex. A lot of times throughout this chapter, we're going to be asked to compare things to the parent function. The parent function of a quadratic is f of x equals x squared. That is the most basic equation we could write and get this shape, this U-shaped parabola. Notice how this has a lowest point here. That's called the vertex. That's where the graph changes directions. That's the very lowest point on this graph, and it's at 0, 0. The axis of symmetry is right over top at x equals 0, basically right on top of the y-axis. But the main difference between a quadratic and anything we've looked at so far this year is look at from this vertex to the next point on the right. The slope we would say is up 1 over 1, so a slope of positive 1. And then from this point to the next one, you would be going up 3 and over 1. So the slope is not the same. There actually is no such thing as slope when you're talking about a quadratic. We're always going to alter or transform our parent function. And to do so, we're going to talk about reflections, stretches, and compressions. The first one is a reflection. That's really easy to see. That's anytime we take a graph and reflect it over the x-axis, which means it then opens down. In order to do that, we are going to add a negative sign in front of x squared. So our a value is negative anytime the graph opens down. Anytime it opens up, our a value is going to be positive. So a quadratic will have either a minimum or a maximum. Okay, it'll always have one or the other. It'll never have both. If the graph opens up, which means it has a positive a value, that means our graph's going to have a lowest point, which we're going to call the minimum value. If the graph has if the equation has a negative a value, it's going to open down, which means it has a top, which means it has a maximum value. So you will always have either a min or a max value. You can shift your parent function left or right. That's called a horizontal translation. remember your equation, which is y equals a times the quantity of x minus h squared plus k. To move a graph horizontally, we're going to talk about adding a number in to this h spot. And if I wrote a minus 2 there, the graph would actually shift to the right 2 units. If I wrote positive 2, it would shift left 2 units. So it's going to be opposite of what you would think. We can also shift a graph up and down. Remember the equation y equals a x minus h squared plus k. The part that's going to shift it up or down is going to be at the end there, the k value. If that said plus 2, it would shift the graph up 2 units. If it said minus 2, it would shift it down 2 units. So that last number just talks about moving a graph vertically. We could also change the steepness or the narrowness of a graph by stretching it. So a stretch, I want you guys to remember that this is making the graph a little bit more narrow. So look at the two graphs that they show you here. One is a little bit more closed, and that's your y equals 2x squared. So that 2 out in front is going to make the, not the slope, but it's going to make the graph increase at a quicker rate. So anytime our a value is greater than 1, and it's actually the absolute value of the a value, anytime that's greater than 1, we're going to call our graph a stretch. We could also compress a graph, which means make the graph wider compared to the parent function. And what that means is basically anytime our a value, the absolute value of the a value, is between 0 and 1, so 1/2 in this example, or 1/3, or negative 1/4. If it's between 0 and 1, that's going to pull the points closer to the x-axis, which is going to make it a wider graph, which means it increases at a slower rate. One of the main takeaways is to be able to graph a function when you come into class tomorrow. So this first one does not look like it's written in Vertex form. However, you could easily write this as y equals negative 4/9 x minus 0 squared plus 0. Those two equations are the exact same thing. And when it's written with the zeros, you guys could tell that the opposite of this, the opposite of 0 is 0, and this number at the end, 0, is our vertex, which is the most important point on our graph, and that's where we always want to begin. So I'm going to plot 0, 0. That's my vertex. I can immediately draw my axis of symmetry through that point because it'll always go through the vertex. I can write AOS at the bottom here and write x equals 0, which would be the equation for it. I need to get 2 more points, one on the right-hand side of the axis of symmetry and one on the left. To do that, I can't really go by the slope. So what I'm going to do is I'm going to pick a number 1 unit away from the axis of symmetry. So down here at the bottom, remember the axis of symmetry is x equals 0. So if you go 1 to the right, you're at 1. If you go 1 to the left, you're at negative 1. So you can pick either of those two numbers. I'm going to use x equals 1, and I'm going to plug that number into my original equation for x. This should be pretty easy to calculate. 1 squared is 1 times 4/9 is negative 4/9. So we get 1 comma negative 4/9 as our second point. So I'm going to go ahead and graph that, which should be right around here. Not the easiest to show, but we can label that to make it pretty obvious. And what that allows me to do is flip that point over the axis of symmetry to get my second point, which would be negative 1, negative 4/9. Now the last step, is to draw a U-shaped graph opening down through those points. So as long as you have a curved line and it doesn't look like a V, that's going to be exactly what you need to show. Now, do you have to absolutely pick 1 or negative 1? No. But if you were to pick a number such as 10, if you picked a number like 10, you're going to get a much, much smaller number, and it's going to be really hard to show that on a graph. That's why I'm always going to recommend just going 1 unit away from the axis of symmetry and plug that number in. That's going to give you the easiest number to graph. On this slide, there's two problems. I'm going to graph number 19, and your homework, part of your homework, other than taking notes, is to actually attempt number 20 on your own. For number 19, I can change this to y equals the absolute, or I'm sorry, y equals the quantity x minus 0 squared minus 9. So my vertex would be the opposite of this number, which is 0, and the same as this number, which is negative 9. So 0, negative 9 is my first point. That means my axis of symmetry goes right through that. And I'm going to write that right below, AOS x equals 0. Now I need to get another point, so I'm going to pick a number 1 unit away. I'm again going to use x equals 1, and I'm going to plug that into the original for x. 1 squared is 1, minus 9 gives us negative 8. So that means 1, negative 8 is a second point on the graph, which should be right about here. Again, label that. Flip that point over, and we're at negative 1, negative 8. And now again, draw the U-shaped graph through that. I will ask you guys to give me two more things anytime you graph, and that's the domain and range. Hopefully we remember the domain represents x values, and these parabolas will always continue to go to the left and to the right. So anytime that happens, it's continuous, and we need all real numbers. So I just drew the symbol there. The range. This graph does not continue up or down. It does continue up forever. And there is a very bottom point here. So we need y values greater than or equal to the lowest point, which is the vertex, which has a y value of negative 9. So y values greater than or equal to negative 9 would be our range. I want you guys to try and graph number 20. Start with the vertex, draw the axis of symmetry, pick a number 1 unit away from the axis of symmetry, and plug that in to get a second point. The second goal, other than being able to graph a quadratic function, is to be able to give the vertex, the axis of symmetry, the max or min value, and the domain and range without graphing. So I would take a second to pause this video and look how they did this problem down here, number 3, to figure out all those different answers. We're going to attempt to do that in the last slide. All right, so for this one, we're trying to figure out each of these 5 answers. So the first thing starts with the vertex. The vertex is always the opposite of the number inside the parentheses, so negative 1, and the number on the outside, which is also negative 1. So our vertex is at negative 1, negative 1. Our axis of symmetry is always x equals a number, and that number will always be the same number as the x value in the vertex. So whatever this number is, that's going to be the same number we write for the axis of symmetry. So x equals negative 1. Next up, min or max value, and that's based off of our a value. Our a value here is positive. So that means we're going to have a regular opening up U-shaped graph, which means that it's going to have a very bottom point, which means it has a min. The min, we have to tell what it is. So we're going to say a min of, and what's going to be the lowest value possible? Well, lowest talks about our y value, and it's always the vertex. So what's the y value of the vertex? And that's negative 1. So we have a min of negative 1. The domain, you don't even have to think about it. It's all real numbers because it continues left and right. The range is what y values do we need. Now, does this graph open up or down? It opens up. So that means we need y values greater than or equal to something. And to figure out that number, we need to know what is the lowest point. So what is the vertex? The vertex is at 1, negative 1, which means we need y values greater than or equal to negative 1. So these two numbers will always be the same. And these two numbers will always be the same. So your vertex gives you the axis of symmetry and the number that you're going to use in your range every single time.